Hi. In this lecture, we're going to do a little sort of bonus. I want to talk about the normal distribution again, and I want to talk about it in the context of a business practice that has to do with quality control that's known as Six Sigma. Six Sigma was a process developed by Motorola, quite a while ago, a couple decades ago, and it had to do with sort of making production processes more predictable so that you had fewer quality errors. So to understand how it works, let's go back and remind ourselves of what sigma is, and then we can understand what Six Sigma is. So remember when we had a normal distribution, right? We had a mean, and then we had these standard deviations, these sigmas, one standard deviation, two standard deviations, and so on, right? And then what we had is that 68% of the time, right, the outcome would lie within one standard deviation, and 95% of the time, it would lie within two standard deviations. So how often would we lie within six standard deviations? So if I went way out here to six standard deviations, I guess that's even further out, how often would I be inside that? Well, the answer is the only time I would fall outside of it would be 3.4 in a million. Okay? So that means that there's almost no way that I'm going to be way over here outside of Six Sigma too big or Six Sigma too small. And so that's going to be the core idea. Let me explain the idea in the context of an example and then take it to the production, how it's used in production. So here's an example. Let's go back to the grocery store. So suppose I run a grocery store and I sell bananas. And on average, I sell 500 bananas a day. I've kept track of my data. It's a normal distribution, and the standard deviation is 10. So what I want it to be the case is that if I have any sort of day within Six Sigma, I'm not going to run out of bananas. Well, this is easy to solve for, right? Because sigma is just equal to 10, right? So that means that Six Sigma is going to be 60. So if I want to be within any event within Six Sigma, I'm still going to be okay. All I need to do, right, is have 560 bananas on hand, pounds of bananas on hand, and then even if I get a 4 sigma event, a 5 sigma event, a 5.8 sigma event, I'm going to be fine. I'm not going to run out of bananas. So that's the idea, right? You want it to be that even if you get a 6 sigma event, things are going to be okay. Okay, so let's see how this works for production. So suppose I'm making some metal part, and this metal part has to be between 500 and 560 millimeters, right? So this is the range. Anything in this range is okay, but if I'm outside this range, then the part's not going to work. So I could be making phones, I could be making car doors, whatever. Now suppose it's the case that, what causes the door to be a little thicker, a little thinner than we want is just a bunch of random things being added up. So I've got a normal distribution. Well, I should be able to make my production process so I get the mean right in the center of that, right? So I've got 530, which is right in the center. But now I want it to be the case that if I have a 6 sigma standard deviation, I'm still going to be okay. Well, this isn't very hard to figure out, right? So we can just say, okay, here's my distribution. 530 is the mean. And I'm going to have a bell curve. It's not a very good bell curve. But I want it to be the case that anything within 6 sigmas is okay. So 560 to 500 have to be, that's got to be my 6 sigma range. So this is going to be plus 6, and this is going to be minus 6. I should put little sigmas here. Okay, so if 6 sigma is 30 above the mean, right, this is 560 minus 530 equals 30. That means I just want 6 sigma to equal 30. So if 6 sigma equals 30, that means sigma equals 5. So what does that mean? That means if I'm running this company, if I'm sort of making these metal parts, I want it to be the case that my standard deviation, when I keep track of the standard deviation of my parts, I want to get that all the way down to 5. And if I get that down to 5, then if I have any event less than 6 sigma, the part's still going to work. Now, how do I get it down to 5? That's not easy, right? You've got to do continuous quality improvement. So the real management practice was not so much just computing standard deviations and figuring out what the 6 is. It was doing all that really hard work that makes it so that sigma falls down to 5. So it could be initially your sigma might have been 30 or 20 or something like that. The idea through continuous improvement is you drive your sigma down so that sigma gets small enough that even if something really bad happens, the process still works and the part still functions and you don't have to do some sort of massive recall. Okay, so that's Six Sigma thinking. What Six Sigma basically tells us is that we can use this idea, right, this model of sort of normal distributions with standard deviations to inform how we run our production processes. And we can figure out, like, we're just making too many mistakes. And if we make mistakes at this level, we're constantly going to have parts not work. Whereas if we can reduce our variation, by reducing our variation, then the process is almost always going to work, right? Our parts will fit in whatever part they've got to fit into. All right, so that's just another example of how we can use this aggregation thing, right? These techniques, these tools we're using in ways that we might never have expected when we first came up with them. Okay, thank you.